Let's take a look at this example. This example gives you this machine. It says, hey, your z or f of x and y is equal to the square root of x plus y plus 1 divided by x minus 1. Okay, very good. So this is my z. Z is equal to, well, here you have a rational expression. On the numerator, you have a radical. On the denominator, you have this linear quantity, and this is your function. You have a function. The very first question that you have is, what is the domain? After finding the domain, you should be asking about the graph of the function. What's the behavior of the graph? Then later on, we're going to talk about the limit. We're going to talk about the continuity. Then we're going to talk about the rate of change and so on. For now, we're going to focus on the domain and the graph of the function. Okay, so how do I find the domain? To find the domain, you have two important things to focus on. For the domain, first, we have a radical. Going back to algebra, when you have a radical of a quantity, any quantity, doesn't matter. Inside the radical with index 2, this quantity must be larger than or equal to 0. We have a radical, so this quantity, you take that quantity, whatever it is, must be larger than or equal to 0. So this is your very first step. This is the quantity inside the radical, x plus y plus 1. This guy must be larger than equal to 0. Okay. What else do I have? I have a quantity on denominator. We have x minus 1 on the denominator. What's the meaning of that? This guy cannot be 0. So x minus 1 cannot be 0. So for the domain of function f, it's going to be the setup. Guys, you have two free variables, x and y, is the set of all points or their pairs, x and y, part of the plane, such that with the condition that x plus y plus 1 must be larger than equal to 0, and x minus 1 is not 0. Okay, very good. So this is your very first step. The base step is to write the domain, then try to simplify what's going on here. How do I visualize this? My domain, then the graph. So the domain of f is the set of all points such that x plus y is larger than equals to -1, and also my x cannot be 1. Okay, so what's the domain like? How do I visualize the domain? It's part of the plane. I already know that, but what's the graph like? Let us graph the domain. Okay, so this is from algebra, basic algebra. Of course, you learn about these inequality in algebra. So you're going to go to x and y. We already know that our domain is part of the plane, all right? The very first one is easy. on the right-hand side. X is not 1. So X is 1 is going to be a vertical line, am I right? X equals to 1 is a vertical line. X is not 1, it's just a dashed line. Okay, it means that we are excluding 1, and this is X not equal to 1. This is this guy here, the vertical line, the dashed vertical line. What about this? X plus Y is larger than or equals to -1. So to graph this guy, X plus Y larger than equals to -1, first we graph X plus Y equals to -1, right? Okay. If X is equal to 0, my Y is equal to -1. If Y is equal to 0, my X is -1. This is my line that I'm talking about here. Now, let us use a checkpoint like the origin, 0 and 0. If you plug in 0 and 0 into this inequality, does it satisfy the inequality? 0 plus 0 is 0. Is it larger than equals to -1? Yes, it is. What's the meaning of that? It means that 0 and 0, the origin is also included on the solution set. So when you're graphing, shading, it must include the origin as well. Very good. So what is the domain? The domain is all these shaded area, and you have to exclude this vertical line, all points on this vertical line. So this is the visualization of the domain of this function. This is the domain of z equals to square root of x plus y plus 1 divided by x minus 1. That's how we visualize the domain. The whole graph of this function is going to be a three-dimensional graph. We're going to use an online website to visualize this function. The reflection of this function on xy plane in 2 dimensions result in the domain of your function.